Assalamu alaikum wa rahmatullah, dear viewers. Today we'll continue with the part 3 of this lecture series, inshallah. In this video, we will learn about different allotropes of carbon. But before watching this video, make sure you have already watched part 1 and part 2 of this series. This is Iqbal sir, and let's start. So, dear viewers, do you have any idea about allotropes, allotropy, or allotropes? Well, allotropy is the phenomenon of existence of an element in two or more physical forms which have different physical properties but identical chemical properties. And the different forms in which an element exists, these are known as allotropic forms or simply allotropes. Carbon also occurs in many crystalline allotropic forms and amorphous allotropic forms. These different allotropic forms of carbon include diamond, graphite, fluorines like buckyball and nanotubes, carbene, which is also known as linear stellenic carbon, Q carbon. They're like ferromagnetic allotropes of carbon, graphene, and amorphous carbon like coal and soot. Remember, all these different allotropic forms of carbon are the purest forms of carbon. They have same chemical properties. For example, if we burn these allotropic forms of carbon in air, all of them will produce carbon dioxide gas, which indicates the all are actually pure form of carbon, but they are having different physical properties. That's why they are allotropes. This difference in their physical properties is because of the difference in the arrangement of carbon atoms in them. Well, in this class we will take a look into the more widely known allotropes of carbon like diamond, graphite, and we'll be having a brief idea about fluorines. Diamond is the purest crystalline allotrope of carbon. Although diamond occurs naturally in some parts of the world like Australia, South Africa, Russia, etc., this diamond can also be synthesized artificially in the laboratory by subjecting pure carbon to a very high pressure of about 50,000 to 60,000 atmospheres and a very high temperature of about 1600 degrees Celsius. This will help us in making artificial diamond. However, the synthetic diamond they are of smaller size. Well, you know something about size of diamond? Size of diamond is measured in carats. Like 1 carat is equal to somehow 200 milligrams. You heard about famous Kohinoor diamond? It's the diamond which decorates the crown of British Queen. Kohinoor is one of the largest cut diamonds in the world, and at present it weighs somehow like 105.6 carats. Yes, it weighs 105.6 carats. You know how much it exactly is? This is roughly equals to 21 grams of diamond. Let's talk about structure of diamond. In diamond, carbon atoms are linked together tetrahedrally. In a tetrahedron, each single carbon atom is bound to 4 other carbon atoms by strong single covalent bonds, which are in turn bound to other carbon atoms. The 4 surrounding carbon atoms lie at the 4 vertices at the 4 corners of a regular tetrahedron. This tetrahedral arrangement of carbon atoms in diamond gives this diamond a rigid 3-dimensional network structure. Properties of diamond. Diamond is extremely hard. In fact, it is the hardest natural substance known. This hardness of diamond is because of its rigid 3-dimensional structure and because of its strong covalent bonds between the atoms. Diamond has a very high melting point as well, because it takes large amount of energy to break the strong covalent bonds in diamond. That's why diamond the melting point of diamond is quite high. It's around somehow 4000 degrees Celsius. Diamond also has a high relative density. It has a density of about 3.51 grams per cubic centimeter. This high density of diamond is also again because of its rigid structure. Diamond is a transparent substance. It appears transparent to X-rays. This is because of its high refractive index. The refractive index of diamond is 2.5, right? Diamond is a bad conductor of electricity. This is because all the 4 valence electrons of carbon in diamond are firmly held in carbon-carbon single bonds, which means that there are no free electrons in a crystalline form of crystalline form of diamond. So therefore diamond is bad conductor of electricity because of no free electrons. However, diamond is good conductor of heat. In fact, diamond has the highest thermal conductivity of any known substance. Uses of diamond. Because of the hardness, diamonds are used to drill, to grind or cut materials in industries by making sharp-edged blades of the diamond. And because of their shiny luster and durability, diamonds are useful in making jewelry such as earrings, nose rings, etc. Diamonds are also used for making dyes. Sharp-edged diamonds are also used as a tool by eye surgeons to remove cataract from eyes with great precision. Nowadays we're having diamond dust. It's like the dust of diamond, and this diamond dust nowadays is used in cosmetic beauty industry. It's used in beauty products in order to reduce wrinkles, etc. Graphite. Graphite is also a pure form of carbon. It's a grayish-black, soft and silvery solid. Graphite also occurs naturally in some parts of the world, like it occurs in China, South Korea, Russia, India, etc. However, it can also be prepared artificially from pure form of carbon in an electric furnace. This needs a very high temperature of about 2000 degrees Celsius. Structure of graphite. Unlike that of diamond, graphite is composed of flat two-dimensional sheets or layers of carbon atoms, forming kind of hexagonal rings. In each layer, in each sheet, each single carbon atom is linked to 3 other carbon atoms in the same plane by carbon-carbon single covalent bonds. These are somehow strong covalent bonds. And unlike diamond, graphite has a two-dimensional sheet-like layered structure consisting of a number of hexagonal rings fused together. These sheets or layers are held together by weak van der Waals force of attraction. You know, van der Waals force, these are the weakest forces of attraction. So one of the weakest forces of attractions. You know. Properties of diamond. Properties of graphite. Graphite is a soft, slippery substance. It's very soft. The softness of graphite is because various layers in graphite are held together by weak van der Waals force of attraction. Therefore, these layers can easily slide over one another. This makes graphite soft. And the density of graphite is relatively much lower than that of diamond. We're having the density of graphite 2.22 grams per cubic centimeter. This low density in graphite is because of wide spacing between the layers and less closely packed atoms. Graphite is good conductor of both electricity and heat. This is because carbon has 4 valence electrons, and in graphite each carbon atom is linked to other 3 carbon atoms. This means only 3 valence electrons are used in bond formation, and the 4th remaining electron is free to move. As a result, graphite is good conductor of electricity and heat. Uses of graphite. Graphite with desired quantity of wax or clay is used to make lead in pencils, which is used in writing. this is the most common use of graphite. In fact, the word graphite comes from the Greek language, and if we translate it, it means to write. And due to its softness, graphite is used to make lubricants like dry lubricants and grease extra, which help in reducing the friction. You know, lubricants, they help in reducing friction. Graphite being a good conductor of electricity, it's also used in the manufacture of carbon electrodes, in the manufacture of carbon brushes and carbon plates. And these carbon plates, these are needed in dry cell batteries. Graphite is also used in nuclear reactor to stabilize nuclear reactions. This is because graphite can absorb fast-moving neutrons. Fullerenes. Fullerenes are a new class of carbon allotropes. They are spheroidal molecules, and they contain even number of carbon atoms in a composition of C2N, where N is greater than or equal to 30 carbon atoms. This means the number of carbon atoms in fullerenes ranges from 60 to 350 atoms or these fullerenes can be prepared by evaporating graphite with a laser. The first identified and the most stable among these fullerenes is Buckminster fullerene or fullerene C60 molecule. It contains 60 carbon atoms arranged in caged shape or in a shape of a soccer ball or football. That's why it's sometimes also known as buckyball. Fullerene C60 molecule or the Buckminster fullerene molecule contains 26 membered hexagonal rings and 12 5-membered pentagonal rings. Although not much of the properties of Buckminster fullerene are yet known, but this Buckminster fullerene, it's a dark solid molecule. It has a very small size, having only 60 carbon atoms. This fullerene C60 molecule dissolves in organic solvents as well. And Buckminster fullerene is neither too hard like that of diamond nor too soft like that of graphite. It's somehow in between the two, graphite and diamond. Fullerenes have found their use in electrical and cosmetic industries. They are used to make batteries. In cosmetic industries, they are used to make beauty products. More specifically, Buckminster fullerene can be used as an antioxidant. It can be used as a lubricant, as a catalyst. It's also used in formation of solar cells extra. Dear viewers, hope we are now able to understand different allotropic forms of carbon, their structures, properties, and uses. For any related questions, comment or mail. Inshallah, you will get this satisfactory answer. Till then, enjoy the video, subscribe to the channel, give your suggestions, and don't forget to like and share. Thank you. Have a nice day. Stay home. Stay safe.